So it's always nice to be here and meeting fellow colleagues, and those might have, we might have went to a different route, but meeting here, it's always give a nice pleasure. And today I'll be talking about NEP. It's a paradigm changing process. And Mr. Greg Fang, he was supposed to present here, but because of the business requirement, he could not. So I'll be presenting on his behalf. And this one, those who attended yesterday, Mr. Keith Couch talked about NEP in his presentation it was more as a trailer, and now probably we will show you the full picture of NEP. But before that, let's give some clarification of the legal requirement that this presentation will have certain forward-looking statements with certain assumptions which may or may not be applicable in all the cases. So yesterday, we talked about various parts of various issues of the petrochemicals. This session is more about petrochemicals. Let's just see about what is the key growth potential in the petrochemicals. There are two specific areas, two light olefins, which is ethylene and propylene. And if you can see this slide, that both ethylene and propylene, both the demands are expected to grow across various regions, very specifically in India and China. The expected growth rate predicted to be around 3%. And that's not end of the story. Like yesterday, it was also mentioned that there are always focus on improving the efficiency, moving to the latest technologies. And there is a chance that there may be those older crackers might close down and people might move to a newer cracker, more efficient one, and this probably will increase this demand by not 3%, but it may be 6%. That is the best case scenario. So definitely there is an increase in the both these light olefins, both in the ethylene and propylene demand. But it also comes with certain, but this light olefin industry also comes with certain challenges. Now there are two types of crackers you all know. One is the naphtha cracker, one is the ethane cracker. Now naphtha cracker, most of in the Middle East and in India, a lot of naphtha crackers are there. Those are very high capacity, but it comes with a certain disadvantage of a higher cost feedstock, low olefin yield, and higher capex, resulting in the lower ROI. The alternate is the ethane cracker, which definitely is better ROI. Unfortunately, the supply is limited, and I think it was also mentioned by Mr. Rajiv Agarwal just now, that this supply and uncertainties of the supply because of the geopolitical reasons makes a lot of challenge in the ethane. On the other hand, for the liquid naphtha, the demand for liquid fuels are declining, so it is possible that the feedstock may be less, maybe easier available for the liquid cracker. But with the focus on the sustainability, again, liquid crackers or naphtha crackers is in a disadvantageous position. So there is a lot of these challenges which comes in the light olefins industry. So essentially what is required is an improved approach to light olefins production. And that's what we will talk about. But before moving that, let's talk about and dig a bit slightly deeper on the feedstocks. And if you see these two curves, and this talks about this feedstock, talks about both propylene and ethylene. And a very logical that ethane, the most efficient feedstock for ethylene is ethane. You get a maximum amount of ethylene and minimum amount of byproducts. And the same thing is true for propylene. So if you use propane and go through propane dehydrogenation route, you get the best yield of propylene and minimum of the byproducts. So essentially, both these ethylene and propylene, if you want to improve its yield and reduce the byproducts, the best feedstock is ethane and propane. And NEP addresses this specific area where it converts the naphtha to ethane and propane, and that's the beauty of NEP. And it becomes the most efficient feedstock. And it comes with a very simple chemistry. Okay, now we'll introduce NEP a bit. If you see, it's a relatively simple process where we have a NEP process unit. Generally, the lighter feedstock is provided as a feed, and then it converts those naphtha to ethane and propane. It can be tuned, and this ethane and propane then subsequently is separated, and separate ethane can be put as a feed to the ethane cracker. The propane, it's an optional product, can be put to the propane dehydrogenation. And ethane gives ethylene. Sorry, my apologies. And ethane gives ethylene, and propane gives propylene. Now, this is a highly tunable, and the overall olefins production is pretty high. It's in the range of around 80%. It has a much less methane and also pretty much less pi oil or pi gas. I don't know what's going on. Not sure. So how it benefits? So NEP, in comparison with mixed feed cracker, because of the efficiency and because of the feedstock, it increases the light olefin yield significantly, which is around 50% to 70%. And it obviously reduces the cost of production, which results in increasing the operating profit. It comes with a lower capex, and capex per metric ton of olefins also reduced significantly, which is somewhat in the range of 30%. And here there is a high feedstock flexibility. This NEP is isotolerant. Essentially, in naphtha cracker, it's sensitive to iso. So if you have a feed, you have an iso component instead of normal component in the feed, the yields are slightly less. And NEP addresses this issue. So NEP is isotolerant. And overall, the CO2 intensity is much lighter, much improved. And one specific thing which I have not mentioned, but here it is now, this is highly tunable. So there is a wide range of ethane to propane we can produce by tuning the reactor parameters. And that becomes a very, very unique value proposition for NEP. And that is the reason we are talking this NEP technology as a game changer in the light olefins. So how does this tuning of ethane and propane helps? So if you see that there are various customers will have a different need. Somebody would need ethane only. So there are the refiners, or there are the processors, they need more ethylene or more ethane. Those ethane-starved customers will definitely benefit from NEP by addressing this ethane gap. If it is, suppose if it is a grassroots and greenfield project, there they might not have fixed it, they might need both ethane and propylene, ethylene and propylene. Yes, that also can be done with using the NEP. Again, there may be in some cases, customer might have to balance between natural gas liquid and LPG, and then the ethane supply. That also is possible, again, to utilize this ethane-only mode. So this is a specific case where option is there with the customer. I mean, think about those cases, like if those options are given, it's always better, because that option helps you to actually invest whatever you actually require. You need not have to over-invest anything. So NEP has this potential to meet a variety of industry needs. Here we will show two case studies. The first case study will be on item number 1 and 2, where it addresses this ethane gap. It addresses a brownfield application. And we will also give one case study for a case which is a greenfield application, where you need both ethane as well as propane. So the first application here, the customer wanted to optimize the existing cracker. The problem statement they had is they want to reduce their propylene production, because the propylene market, because of the overcapacity in China, is really in a dire need, and a lot of extra capacity is there. So they want to reduce the propylene. They want to increase the ethylene, and they have a flex feed furnace where it can take both naphtha as well as ethane. So this is the problem statement we came up with to have a discussion with the customer. In the left-hand side, you see what is the configuration for existing mixed feed cracker. It has 2 dedicated liquid furnaces. It has 2 dedicated gas furnaces. The gas furnaces are fed by propane. The dedicated liquid furnaces are fed by naphtha. And then it has 2 flex furnaces. It can have both naphtha as well as a liquid as well as gas. And that also they are utilizing naphtha. In the revised configuration, what we suggested is to reduce naphtha or remove naphtha from one of the flex furnaces, use the NEP, divert this naphtha and some extra naphtha to this NEP, produce ethane, and that ethane then get fed to these 2 flex furnaces, and then the propane goes as usual to the gas furnaces. So this is the change which we have suggested. So here the NEP was tweaked to meet this ethane production, and essentially what happened is they have to shut down naphtha to one of the furnaces, added some more more naphtha, which around 800 kMTA naphtha has been fed to NEP unit, and this provided a ethane of around 625 kMTA. What it resulted with this tuning? It resulted in an increase in the propylene by around 300 kMTA, whereas the reduction, increase in ethylene is 300 kMTA, and also resulted in reduction in propylene as well as reduction in pi gas or pipe oil. significantly. And the best part is it is a low-cost modification. Here there is no big ticket item to change on the naphtha cracker. Yes, the the separation section need to be worked out. Obviously there will be the challenges, but this gives a very nice IRR of around 20% with a total investment of 300 million. So it gives a very, very nice what the customer needs, a solution fully catered to the need of this particular customer. The second one will be on, coming to this second case, this is on the, this is a greenfield project. In this greenfield project, the customer wants, it's a bit, if you see the API, it's a bit lighter crude. And the objective here is maximize the polyolefins, but customer has not fixed what ratio they want ethane and propane. So they are flexible on that. But one thing they are clear, that they don't want too many byproducts, especially on pie oils and all the stuff. And obviously they want to maximize the ROI. So here it shows two solutions. One is the conventional crude to chemicals, very typical one. It's a simplified. And you have from the crude, you have a gas separation plant, you have a hydrocracker, and then the product goes to the mixed feed steam cracker. You have polyethylene, we have polypropylene, you also have pie oil and pie gas. Our suggestion here is to convert this hydrocracker, I mean, not convert, it's a greenfield. So this hydrocracker is configured as a advanced hydrocracker, which gives only LPG and light naphtha. And then all this LPG and light naphtha is fed to the NEP unit. NEP produces the ethane and propane based on the whatever the tuning factor is. And then the ethane is sent to a ethane cracker instead of mixed feed cracker, and the propane is sent to a PDH unit. As I was telling in a couple of slides back, that if you get ethylene from ethane and if you get propylene from propane, you minimize your byproducts, and that is what we are seeing it here. And if I compare the yields based on whatever we did the study, so on conventional crude to chemical complex, where the polyolefins yield was about 50%, around 53%, and the pie oil plus pie gas is around 35%, with a E to P ratio of 1.8. Now, here E to P ratio is why important, that it's a fixed E to P ratio. You cannot change it. On the other hand, when you go to the NEP-based crude to chemicals, you can have a higher polyolefins yield. It's in the range because we have looked into 3 different scenarios because the customer did not fix on ethane to propane ratio. We looked into high E to P ratio, mid E to P ratio, and low E to P ratio. E to P ethane is to propane ratio. And the total polyolefins, total E to P comes out to be somewhere between 83 to 86%. Here you directly get the aromatics. Yes, you get certain amount of aromatics, around 13 to 15% aromatics from this NEP, but you get basically the mixed xylenes and benzene and toluene. And your pie oil and pie gas yield is significantly less than the typical mixed feed steam cracker. And this results, if we consider the base value of the investment, for the crude to chemicals. This gives an incremental IRR about 4 to 5%, significantly good. And with an incremental expenditure just 10 to 20%. So certainly it's a bankable, and it's very, very effective, and the best part is it can be suited to the requirement of the customer. So here is the commercialization update. So right now our demonstration unit for a Chinese company is, well, we just completed the design last week. We completed the basic engineering package, and now it will go for the plant startup is second quarter 2026, second half 2026. And we are also moving with technology approval from Chinese government. We also signed the MOU with Petrorabig, and that is for the first commercial unit, which is the previous one. This one was a demo unit. For the Saudi unit, it is pretty much a first commercial unit with a planned startup of 2025. There are the discussion with about 15 more clients, including Indian clients, and there are a lot of interest in India, and there are some advanced level discussion going on. If everything goes right, maybe we will get some more licensing, probably end of this year or early next year. Another good part is NEP can be offered as a modular unit, and that will be a big advantage and as a perfect solution for brownfield applications. And obviously EOP is prepared to license and guarantee the NEP. Overall, I think it's very nice to see there are a lot of good interest in NEP because of its simplicity, its flexibility, and I think yesterday it was talked about bankability and flexibility, and that is exactly which comes to this light olefins. So it converts readily available naphtha and LPG to a tunable amount of ethane and propane, and it's get a very efficient ethylene production, ethane to ethane steam cracking, which becomes the very efficient production. Generation of propane is optional. If you need, yes, you require, then you can. If it is not required, then it can be converted to ethane only. If it is back integrated, added this advanced hydrocracker, then it becomes a perfect solution for C2C complexes. And as I said earlier, it's an efficient, flexible, and bankable olefin production. And it's ready for license, and again, EOP is there to help you out and definitely try to meet your requirement. Thank you so much. Thanks.